Okay, so think about this. Your cells are constantly changing who they are just to survive the environment you're putting them in. This deep dive is basically a shortcut to understanding that survival manual. We're talking about cellular adaptations.
Right. These are the reversible changes your cells make. Things like size, number, even their basic function, all in response to stress.
And these aren't random, are they?
Not at all. They're very calculated survival strategies. We're going to unpack the four main ones.
Which are?
Hypertrophy, getting bigger. Hyperplasia, making more cells.
Yep.
Atrophy, which is shrinking. And then there's metaplasia.
The really critical one.
The one where the cell fundamentally changes its type. Yeah.
Right, let's start with getting bigger. Hypertrophy. A cell increases in size, the whole organ gets bigger. We see the good version of this, right? The physiological kind when you lift weights and your muscles grow.
Exactly.
But if getting bigger is a good adaptation, why is it so often dangerous when it happens in the heart?
Well, that's the key difference between physiological and pathological. It's all about context. When your blood pressure is chronically high, your heart's left ventricle, it has to work so much harder.
So it bulks up, just like a bicep.
It does, but it's a pathological hypertrophy. The muscle gets so thick and rigid it can barely move, it becomes inefficient.
I see. And what's happening on a molecular level to cause that?
It's a huge spike in protein synthesis driven by growth signals like IGF-1, but that adaptation, if the stress continues, carries a really high risk of cardiac failure.
Okay, so moving from bigger size to just more cells, that brings us to hyperplasia.
Right. A straight-up increase in the number of cells.
And there are normal examples of this, I assume.
Oh, absolutely. Think about liver regeneration after a part is removed or hormonal changes during the menstrual cycle. Totally normal.
So where does the pathological risk come in?
It usually comes from excessive hormonal stimulation. A great example is endometrial hyperplasia. You're forcing cells to divide way beyond their normal limits, and that creates this perfect chaotic environment for malignant changes.
So you're creating an opening for cancer.
A very specific known risk of progression to carcinoma, yes.
That's growth. What about the other way? Atrophy. The cell shrinks because of, say, disuse or illness. It's not just fading away, though, is it? It's actively dismantling itself. How does that work?
It's fascinating, really. It uses two specialized molecular disposal systems. Yeah. First, for small individual proteins, it uses the ubiquitin proteasome pathway. It basically tags them for destruction.
Okay, like putting a trash me sticker on them.
Exactly. But for the big stuff like whole organelles, old mitochondria, it uses autophagy.
Autophagy?
It literally builds a wall around those parts and digests them with lysosomes. It recycles them for energy and shrinks down. That's why you see severe muscle wasting when a limb is in a cast.
Right. So we've covered growth and shrinkage. But the last one, it feels different. Metaplasia. You called it a cellular identity crisis.
It really is. It's a reversible change where one adult cell type is completely replaced by another.
Why would the body do something so drastic?
For immediate survival. It's a defense against chronic irritation. Think about a chronic smoker. The delicate cells in their bronchial tubes can't handle the smoke, so the body replaces them with tougher, squamous cells.
Wow.
Or in someone with chronic acid reflux, GERD. The esophagus lining gets replaced by cells that are more like the stomach's lining to handle the acid. That's Barrett's esophagus.
So it's replacing a vulnerable cell with a tougher one. It sounds like a smart, short-term fix.
Yeah.
But there has to be a catch.
There's a huge catch. The problem is instability. By forcing that change, the cell is abandoning its normal genetic programming.
And that's dangerous.
It's incredibly dangerous. Metaplasia is a known precursor state. It has a high risk of progressing to dysplasia, and from there to full-blown malignancy. The survival mechanism becomes the long-term threat.
So when we boil it all down, what does this mean for you, the listener? These 4 adaptations. They're your body's way of screaming, I will survive this stress. But if that stress, high blood pressure, hormones, irritation, isn't removed, the strategy itself can become the disease.
That's it exactly. And here's the thought to leave you with. For metaplasia to happen, the underlying stem cells have to be reprogrammed. They have to pivot almost instantly to a new identity to protect the tissue.
A pivot under pressure.
Immense pressure. So think about that. How quickly can a cell just throw away its original blueprint for a new one? And what kind of genetic instability does that swift, desperate bargain for survival really cost the body in the long run? That's something to think about.